Hello, class. Welcome to our next set of slides. Today we're going to be talking about markets a little bit, demand, and flu shot shortages, in addition to a few other things. So I just wanted to give you a broad sense of why this model is developed so much in your principles class, and then why we start with it. So there's supply and demand model can inform a number of different questions. And I just listed out by no means exhaustive list of some of the things that supply and demand could help inform us that we're interested in the field of economics. So the allocation of flu shots would be one, and one we'll dive into at the back of this paper. Toilet paper, which is kind of an odd topic. Consumer and firm behavior, which is kind of like one you've heard of. Price sensitivity is captured by supply and demand models, minimum wages, so government policies and control, taxes, welfare in the sense of how well off somebody is, not payments, changes, any of the things that determine supply or demand can be thought about in this framework, and then also market power, which we'll briefly discuss at the end of the class. And so this general nature with which you can use supply and demand makes it attractive for knowing this kind of general framework to apply it to a lot of different problems as kind of a workhorse. So just kind of some high-level intuition. The supply and demand model is just seeking to gain insight into why people trade in an abstract and flexible way. And so really the logic that's embedded in this model at a high level is that people are buying things because it makes them better off. They demand the good. So it'd be like you buying food in a market. And sellers, so they sell if the price is greater than the cost, they'll supply the good. And something that you do is you sell your labor in a labor market, or if you're not now, you plan to after you graduate. So something to think about is that this transaction does not require monetary currency. So like in a grade school lunchroom, you just have food being traded for food, and money would just help facilitate transactions, which is more under the umbrella of macro. But you can kind of just think about it like it's easier for an electrician to buy video games for the kid if they don't have to pay by installing light bulbs for the video game store for the next year or whatever. So money just helps facilitate these transactions in the supply and demand framework. This market is anywhere that a transaction takes place. And if you want to get more kind of intuition of the background of markets, you can watch this YouTube video, or you can look at this economics article on settings in which equilibrium is actually reached in real life to get an idea of environments where these results have been replicated in. So I just want to briefly get through the assumptions of supply and demand, which is pictured in this graph or picture here on the right. So there are many buyers making up the demand curve. There's kind of many sellers making up the supply curve. Every product being sold in the market is the same. You have perfect information, so you know everything about the products and the buyers and the sellers. And roughly, there's rational buyers and sellers. So these should look familiar to you. And these buyers and sellers are making decisions in a careful enough way that, and these decisions are being made to help maximize their own well-being. So a supply, I'm going to get more into this in the next set of slides, but just to give you a background, supply curve is just kind of assuming that sellers produce or sell more if prices rise. So as you produce more, the cost to produce it increases, roughly. And so to produce more, to be induced to produce more, a seller is going to have to receive more for selling their product. And so if you're investigating the effect of a change in the price of good G on the quantity supplied, we assume that other factors affecting supply are constant. And that's all I have to say about supply. For now, I want to zoom in on demand. So it assumes that buyers buy more if the price is low and vice versa. And this can be really roughly summarized as assuming rationality, which will give a more technical definition to rational preferences when we get into consumer choice in Unit 2. But I wanted to put down a mathematical representation of a demand curve here, which you've probably seen in the book. So quantity demanded for good G is equal to a constant C, that's that intercept here, minus alpha, which is the slope of this line, times the price of a good right here. And so we have alpha being greater than 0, so that's kind of the law of demand. Price of good is greater than 0, so non-negative prices for goods seem pretty realistic. And this constant 0, which just basically means like if the price is 0, then at least something will get consumed, assuming C is positive. So demand obviously depends on other factors too that I'll talk about next, but they're not modeled on the simple demand curve here. The equation I've shown you, this QDG, is considering ceteris paribus changes in price. So I want to drill in more deeply and give you an illustration of what the law of demand looks like. So let's consider a point on a demand curve, which is just that at price equals 10, right here, the quantity demanded also equals 10. And so this is a point on the demand curve, on our hypothetical demand curve. Let's consider all prices less than 10, which is represented by this gray box that I've drawn in here. And then let's further divide prices less than 10, and then the quantity is less than 10 too. It's represented by this gray box here. So that would mean that if the price was less than 10 and you purchased less than 10, which you were purchasing at price equals 10, this would be a violation of the law of demand, because it would mean that at lower prices, you're buying less of the good. And that is not possible. It's possible for a specific subsample of types of goods, which are called luxury goods. But in general, the law of demand means that nowhere less than price is 10 and quantity is less than 10 should be on this demand curve with this point of price 10, quantity 10. However, at lower prices, a good is bought more, which would be the other half of this box over here. And it means that at prices lower than 10, you buy more than 10 units, which is consistent with the law of demand, which is that at higher prices, consumers buy less. So there's a colorblind friendly image here. If you struggle with red-green color blindness, so hopefully that helps out. And by similar logic, if you consider prices greater than 10, you can't buy more than 10 units when the price is higher than 10 and be consistent with the law of demand for this example. While if price is greater than 10 and you buy less than 10 units, that would be consistent with the law of demand. So I just wanted to give this illustration to you of the law of demand in terms of price. But there are other things that also affect demand, which you've hopefully seen before. So one of those things is income and wealth. The amount of money you have influences how much of a good that you buy. For normal goods, if your income goes up, your quantity demand of that good goes up because you have a greater willingness to pay or ability to pay specifically for that good. While with inferior goods, if your income goes up, the quantity demanded goes down. So that would be like hot dogs and ramen noodles and things that you buy when you're just kind of skating by. Preferences are also in the demand curve. This is what we're doing more specifically in Unit 2, but to give you a high-level view, this is how a consumer values consumption of goods and services. And it's encoded into a utility or approximately a happiness function by how we write utility being a function of consumption. A realistic assumption is that would be desirable to appear in our utility functions is diminishing marginal utility. So diminishing marginal utility means that there's decreasing happiness per additional unit of consumption. So like you have your first slice of pizza, it gives you the most happiness. The second slice of pizza gives you a little less happiness. And by the third slice, or fifth or sixth slice for me sometimes, of it, you're finally full. And by the seventh slice, you're so full that that additional slice then marginal utility could go negative, so that you're getting negative effects to your total utility of consuming another unit. And so a couple of functions that would be consistent with a diminishing marginal utility of consumption would be like, say there's a good X, and your utility equals the square root of X, which can be written in any of these three ways, which I'll use in this course. And basically this function is a decreasing function, so that it, I don't know which way it will go up, but as you consume additional units, you receive less utility. You can just plot out y equals square root of X to see that. Next one, another one that would give you diminishing marginal utility would be natural log of X. The problem with natural log of X is it's not defined at 0, but that's more of a mathematic peculiarity here that we don't need to get into too much. Over here, there's a picture of somebody preferring apples to oranges and oranges to bananas. So this would be like saying they get the most utility 3 from an apple, the next most utility 2 from an orange, and the third most utility or happiness 1 from a banana. And so just another example, I'm trying to give you a lot of them, it would be like a utility of a dog, or the happiness for a dog could say, well, it depends on how much their pet and how many treats they have, and whether those are substitutes or complements depends on how they're related to each other in this utility function, which we'll get into more with partial derivatives. But for now, I just put these parameter restrictions on here that says that dogs like treats at least 2 times as much as they like being pet. And just the last thing is there's no diminishing marginal utility of either of those for a dog, which is just kind of assumed in the utility function because they're not square rooted or taking the natural log of, or some other way to give them diminishing marginal utility. So another important thing would be pricing related goods, and this is encoded into utility functions by what we wrote down. It just means that demand depends on the prices of related goods, not just the own goods price. So you can see that one for substitute goods, an example would be Coke and Pepsi. And you know that if the price of Coca-Cola goes up, then the quantity demanded of Pepsi will also go up because they're substitutes, they're very similar. And if Coke gets too expensive, then you can just have a pretty similar product for Pepsi. And you can see that in this demand function for, say, Pepsi, where if the price of Pepsi goes up, then the quantity demanded of Pepsi will go down because of this minus sign right here. And if the price of Coca-Cola substitute goes up, then the quantity demanded of Pepsi will also go up. And then the opposite of that would be a complementary good. And the example I'm giving you here is peanut butter and jelly. So people like peanut butter, but they like consuming it more with jelly. And so we could say that the price of jelly goes up, then the quantity demanded of peanut butter goes down because you like consuming those goods together. And you can see that in this utility function for, call it jelly here, because if the price of jelly goes down, PG, then you consume less jelly. And if the price of peanut butter goes up, then you also consume less jelly. Where the difference between these two is that substitutes and complements affect the quantity demanded of a specific good differently. And you can prove in numbers and plug in numbers and prove it for yourself if you like. So the last thing that affects that I'm talking about now, or second to last thing, is expectations. How much you expect the market to change in the future determines the quantity demanded now. If you expect the price of oil to increase in the future, then you might buy more gas now. And then the number of buyers. So if there's more buyers in the market, it leads to greater market demand. That shouldn't be too much of rocket science for you guys. So quantity demanded, I want to talk about now. So we use quantity demanded to refer to a specific point on the demand curve, whereas demand would refer to the entire curve. In the example, a point on the demand curve is shown. So here's our imaginary point here. And this can be interpreted as at price equals 3, quantity demanded equals 17. So quantity demanded is a function of what the price is. Now let's say that the seller of the good decides to increase the price. A caveat is that you have to notice that this is an abstraction. How much the price actually changes also depends on other buyers and other sellers as well. But let's say the price is raised very high from price equals 3 to somewhere price is greater than 20. At price is greater than 20, quantity demanded is less than or equal to 0 because no one wants to pay $20 for whatever good or 20 for whatever good this is. Another way that can be written is quantity demanded is less than or equal to 0, conditional on, that's the vertical line, price being greater than 20. So the next thing to understand kind of the applications with this is market equilibrium. And we'll discuss more in detail, but market equilibrium is where the price moves towards in response to buyer and seller interaction in the absence of a government intervention. So let's say that I go out looking for a home and I come across a home that I like and I start talking to the landlord and he's like, this is going to be $500. And I say, no way, man. That's way too expensive for a one-bedroom apartment. We're good time. He says, all right. So I go to a different landlord and I say, well, he says $450. I'm like, well, I don't know. That feels kind of expensive also. So I go back to the first landlord and say, well, this guy will give it to me for $450. But that guy says, all right, fine. You can have it for $450. So prices are moving towards equilibrium price in response to the interactions of buyers and sellers. And something neat about that is that the market equilibrium is the most efficient outcome. That means there's no waste or shortage at that equilibrium price. And by way of it being the most efficient outcome, it maximizes the well-being of buyers and sellers. If you want, you can see how a lab market gets there in a classroom using this lab experiment at this link. And I remind you that the slides are online eCampus as well. So the next thing that we have to do with supply and demand is shift supply and demand curves in response to market scenarios that might happen so that we can get insights into predictions about how changes will affect markets. So let's say that an example from my personal life is the good fireworks, those that go up in the air and go boom, became last minute legal in West Virginia last minute in 2016. So I signed up to manage a tent. Now let's just assume that the assumptions for perfect competition are satisfied, and so we can model the fireworks tent market using the supply and demand framework. And so the light blue line is the supply of fireworks tents, and the dark blue line is the demand for fireworks from fireworks tents. Scenario 1, let's just say that there's more tents over time. How would you model that in the supply and demand framework? Well, this could be modeled as a parallel shift out from the old light blue supply curve to a new bright gray supply curve. So this parallel shift out. And this gray represents how new tents coming into the market affects the market. And so, or the model of the market. And I'm going to call that supply prime in any supply and demand graphs, where I change from the original supply to a new supply in response to something happening in the market. Let's go back to our original supply and demand graph. Let's say a different scenario happens. Let's say that I'm a firework tent owner and I know that there's these stimulus checks going on. Well, we know that those are serve as an income shock to people who buy fireworks. And so what happens when to the demand for fireworks when disposable income increases suddenly due to a stimulus check? Well, the fireworks tent operator would know that the demand curve this navy blue curve shifts out to this navy gray demand, this new larger demand because people have more money, demand prime. And so we know that those would affect our predictions about what we would expect equilibrium price and quantity to be. Before the change, it was here, the intersection of supply and demand. And now the equilibrium price is higher, the equilibrium quantity is higher after more income is given to buyers. And that's at this intersection of the old supply curve and the new shifted out demand curve right here. So these scenarios should look familiar to you. Hopefully you've seen them in Econ 201, but we'll have practice with them in this unit as well, in the homeworks also. The last thing I want to talk about is a flu shot shortage, given that we're in the middle of a pandemic right now. If we do get a vaccination for COVID-19, I want to talk about different ways that that could proceed in the market. So let's assume that perfect competition is a reasonable assumption for a flu shot market, so it can be modeled with the supply and demand framework. And we know that prices are converging towards this equilibrium price, which moves quantity supplied towards here and quantity demanded towards the equilibrium point as well. And now I just drew in labels for the equilibrium price in terms of percentage of P star and equilibrium quantity in terms of percentage of Q star. So this is 100 because this is 100% of P star and 100% of Q star. Now in 2004, 46% of expected flu shots were contaminated, making them unusable. And so we had this shock, which happened so suddenly that supply and demand weren't able to adjust, and that P star wasn't able to adjust to clear the market at a new P star Q star. And so in response, the government decided to urge young people to forego shots, but not enough people were discouraged to present the shortage, so the price due to this price not being adjusted. And so P star, what it would have been before the shock to the flu shot supply, which took us from equilibrium supply to 54% of equilibrium supply, this P star, it hasn't adjusted at all. It's been forced to stay at this by the government, and because healthcare markets don't have the most fluid prices. And so P star equals the price after contamination equals the same 100. And so what happens is because the price is 100, there's still 100 units demanded at price equals 100. However, this is the amount of supply that there is because 54% of it was contaminated. And so what you have here is a shortage where quantity demanded is 100, but the quantity supplied is only 54. And so 46% of the flu shots are still demanded, but they just can't be supplied anymore because the price hasn't adjusted. And so we know that if the price isn't adjusted, that we'll have this shortage at the old P star. And this could be a problem because there could be different group elasticities. So the different needs for high-risk groups adjust their relatively price inelastic. So this dark blue is a relatively risky group, and the dark gray is a relatively healthy group. We know that if you change the price for the risky group from 50 to 100, they only demand 25 less shots. Now, if you're on the healthy group's demand curve, the price is 50 and you double it to 100, now they're just demanding 100 shots less compared to only 25 for the risky group. So we know that the risky group is much less sensitive to the price because they need the vaccination to stay alive. And so that's just like another application that we can use for supply and demand. And I'll get more into these elasticities in the coming weeks. So the conclusions of these slides are that supply and demand is a flexible model for making predictions in many scenarios. Supply and demand depends on price, and demand depends on several factors. And supply and demand can be used for insights into markets as diverse as fireworks and flu shots. And so that's all for these slides. Thank you.